data and method. We can show in this slide have more than parameter that will be input in the MATLAB program to build the geomechanical model to solve the problem within the Hartha formation that we can note in the next slide. Next slide, please. When using more than parameter like raw solid, raw fluid, diameter hole and diameter drill pipe, ROB, yield point that we use to build the geomechanical model in the complex way by using the MATLAB program to predict the optimum mud weight that using in the drilling Hartha formation. Next slide, please. From the previously program, we can show this result. We have an inclination angle and mud weight in the right side and the azimuth around the cycle. When have an inclination angle 0, approximately the mud weight have 2.3, and when increase azimuth and inclination angle, the mud weight will be increased. This is figure optimum mud weight with the respect azimuth and inclination angles. Next slide. This figure is explained for the azimuth within inclination angle and mud weight, explained more than detail previously figures. We can show the blue line in this figure. We can note when beginning from the deviated from the vertical section, the mud weight approximately 2.1 approximately. When the well start deviated, the mud weight will be increased according the inclination angle and azimuth. Next slide. This is figure flow rate versus angle when RPM and ROB is various. We can note the line, the green line have red line, please. It have ROB and RPM, ROB 24 and RPM 240 will be a flow rate approximately 2000 and will be increased linear to the stable to the zone and will be get a stable for angle about 45, and when various within ROB 24 and RPM 210 line below, the flow rate beginning from 1900 and will be increased linear with angle 45, and another line is green is less than value from RPM and ROB. Next slide. This slide is show the maximum parameter that will be affected on the drilling optimization, that beginning from the maximum inclination angle in the above with mud weight, the drill weighting of the drill pipe and drill pipe length, that will be various with the another parameter that affected of the drilling. Histogram parameter affecting the drilling Hartha limestone. Next slide, please. Conclusion, our model considered ROB and RPM with the mud weight and inclination angle. Meticulous drilling design should be considered to not find only optimum solution of the problem, but also avoid the problem interfaces. This provides tensile failure investigation and main reason behind of the severe of the loose circulation. In addition, the sensitive analysis, the main parameter that affected the differential stack as well as maximum overball to realize the BHA out of the hole, and monitoring the drilling environment based on the some guideline in the paper to might reduce the hard rhyming problem. A variety of the well-versed training technology can be used to mitigate or avoid the loose circulation of hard formation, such as fracture propagation resistance or stresses cases. The two methods have been provided to prevent mud loose, especially in the natural or the induced fracture. Two methods have been provided to prevent mud loose, especially in natural or induced fracture. The lifting capacity of the drilling fluid might be optimized and ensure suitable hole cleaning with the respect to wall inclination, rate of penetration and revolution per minute, and the fluid properties. Next slide. Thank you. Okay, I am finished. I am finished my presentation. Yeah. Okay. Okay. نفتح المايك سبيكر خلينا نسمع شيء. Please, again, question. I cannot hear you. Mechanical mastocytic, companion mastocytic. Heart formation consists of geochorion, organic limestone, bed shell, chalk, and limestone marl. The depositional environment of the heart formation is four-leaf and the shoal environment. We can see the isomap map. The heart formation is distributed in all regions of the Iraqi in the different color with the different thickness. We will focus the study on the southern of the Iraq in the square yellow that will be seen in the southern Iraqi. Next, please. Next slide. Slide number 5, please. Drilling challenges in the heart. International companies consume about $9 million yearly to solve MBT problem. Non-productive time have escalated because of loose circulation, differential stack, tight spot, hard grinding, and drilling practice with the lifting capacity. We can see this picture. We have a more than problem with this to reduce of the with the well. Tight track and the tight spot in the right figure. Start changing tight spot. Tight spot have more than problem with this well with 13. And figure below we can see more than wells X1 to X2 to X10 with the time. We can see the X1 wells have more time to drilling it within the heart section, and when they're using the optimum drilling, we can reduce the time of the drilling wells. Next slide. Data and method. Drilling data from more than 20 wells we talked about in the previously slide, from the vertical and the deviated, has been examined to determine what cause of the problem in non-productive time heart formation. Several technologies have been used the proprietary to mitigate the loose circulation, such as optimum mud weight, reduction, loose circulation material, decision tree, and the managed pressure while drilling. Geomechanical investigation of the heart limestone formation, abstractal orientate, the well bore was carried out to determine optimum mud weight to prevent the drilling-induced tensile failure. Next slide. Yeah, I'm with you.